Alright guys, welcome back to the channel. Today we're going to be going through some more difficult type exam style questions, particularly on the integration side of things. Now before getting into this guys, make sure to, if you haven't already, to click the link down below and visit the Quick Maths platform for more in-depth videos like this. We currently only got 4 spaces left for the first free month, so completely free of charge. We've got 4 places left, and we're giving away free tuition for the month. That's going to be weekly tutoring sessions twice a week. And not only that, we've also got courses that go into this in a lot more detail, the harder type questions, which is something that not a lot of courses are offering at this point. Plus, we've also got university application support coming out soon as well. So if you're keen for that, check that out. In the meantime, let's crack on. So question 4. Let f of x equal 10x plus 9, 2x plus 1. Okay, cool. My pen's not working here. Try blue. No? Okay. We'll express f of x in partial fractions. So what we're going to do here, we're going to say find I. I'm going to say, listen, we're going to say let 10x plus 9, 2x plus 1, 2x plus 3 squared equal a, 2x plus 1 plus b, 2x plus 3 plus c, 2x plus 3 squared. Okay, I'm going to simplify this. I'm going to get, let's see, 10x plus 9 is equal to a. That's going to be 2x plus 3 squared plus b, 2x plus 1, 2x plus 3, just 2x plus 3 there, plus c, 2x plus 1. Okay, so what we're going to say? Well, let's say now, in fact, let's say let x, okay, equal negative half. Now, why am I saying negative half, guys? Because if you put negative half, oh, this pen isn't working. It's fine. If you put negative half into 2x plus 1, 2x plus 3, or just 2x plus 1 for that matter, you're going to get 0. So it's going to help us isolate the a. So what we get then is 10 negative half plus 9 is equal to a, 2 negative half plus 3 squared plus b. Well, the b is going to cancel because we're going to have 0 there. And when you put negative half into 2x plus 1 solely, it's also going to give you 0. It's also going to give you 0. Okay. So what do we get from here? Well, what we get from here, guys, is negative 5 plus 9. Okay. Is going to equal a negative 1 plus 3 squared. Okay. Which is going to give me what? Well, what that's going to give me, guys, is 4 is equal to 4a, which therefore tells me that a is going to equal 1. Okay, so we got a. Meanwhile, I'm going to say let x equal negative 3 over 2. Why? Because when we plug negative 3 over 2 into 2x plus 3, 2x plus 1, so yeah, just into 2x plus 3, we're going to get 0, and therefore we can isolate and get c. So I say fine, 10 negative 3 over 2 plus 9 is equal to a, 2 times negative 3 over 2 plus 3 squared plus b, negative 3 over 2 plus 1, okay, and that's going to be times by 2 times negative 3 over 2 plus 3 c 2 times negative 3 over 2 plus 1. Okay, and that's a bit hard to see. But here's what that's going to give you guys. It's going to give you negative 15 plus 9. It's going to equal a times 0 plus b times 0 plus c to the negative 2. Which therefore gives me negative 6 is equal to negative 2c, which therefore means that c is equal to 3. Alright, now we've got C and we've got A, but now we need B. Now how are we going to get B? Well, a good way to get B here, guys, is to say, well, if we let x equal 0, we've got A and we've got C. If we let x equal 0, we're just going to have constants, so therefore we can find B. So I can say, let x equal 0. Therefore, what we get is 10 times 0, okay, plus 9, it's going to equal 8 times 0, sorry, not 8 times 0, it's going to equal A, 2 times 0 plus 3, squared, plus B, 2 times 0 plus 1, okay, 2 times 0 plus 3. Alright. Plus C. 2 times 0 plus 1. Okay, which is going to be what? It's going to be 9 is equal to 9 is going to equal 9a. Okay. Yeah, 9 is equal to 9a plus 3b plus c. But now, remember, c is equal to 3 and a is equal to 1. So 9 is going to equal what? 9 is going to equal 9 times 1 plus 3b plus 3. Okay? Which tells me what? That 9 is equal to 12 plus 3b. So b then is going to equal negative 1. Okay, guys. So therefore, what we can say, right, we can say that f of x is going to equal 1 over 2x plus 1, because we've got a there. Okay, minus b. It's minus 1 over 2x plus 3. Plus c over 2x plus 3 squared. Plus 3 squared. Okay, and that will be the answer for part A. Part I, sorry. Now for part II, it's a similar story. For part II, all we have to do is find the integral of that. Okay, so f of x is now this thing here. So we just need to find the integral of this. So I'm going to say, fine, the integral between 1 and 0 of f of x is equal to the integral between 1, 0 of this over here. Okay, dx. In fact, it's really put f of x dx here. Okay. Which is going to give me what, guys? Well, what this is going to give me now is, I can say the following. It's going to give me, well, firstly, actually, what we need to recognize here is we need to get this in the form of f dash of x over f of x. Okay. Let me just highlight this in red. Very important. Okay, we need to get it in that form. So how are we going to do that? So what we're going to say, okay, is going to say a half 1, 0 2 over 2x plus 1. Okay. Alright, and why are we doing that? Because if you look here, geez, I just want to get it red. What's going on with that thing? Okay, whatever. So if you look here, half times 2 equals 1, which is the same thing as saying this. Okay. So what we're actually doing is splitting the integral into different integrals now. So minus, and for this one, it's going to equal what? It's also going to, so we've got dx there, so it's going to equal a half to 2x plus 3, okay? Because remember, the derivative of 2x plus 3 is equal to 2, okay, guys? Cool. Plus, what we're going to plus here? We're going to plus, now this is a bit different. This is a bit different, because what we can say is we can take the 3 out, and what we can say is the following. We can say plus 3, 2x plus 3, negative 2. So it's a classic type integral here. And then we just go from this. So what this is going to give me is a half ln 2x plus 1 between 1 and 0 minus a half ln 2x plus 3 between 1 and 0 here. Okay, so I'm going to say 2x plus 1 for the first one, plus 3. Okay, and what we're going to do is we're going to add 1 to the power. So 3, 2x, 3, negative 2 plus 1, negative 1, 1, 0, like that. Okay, and we're going to divide that by 2 because of chain rule. Okay, so what we're going to get is a half of ln 3 minus ln 1, well, ln 1 is equal to 0, minus a half of ln 5 minus ln 3 plus 3 of what? Well, we could say 3 over 2 here first. And what's going to equal? It's going to equal negative negative a fifth. Okay. It's going to equal. Let me see. negative a fifth, okay, plus a third here. Okay. Cool. All right. Now, from here, it's going to say fine. Well, what this is going to give me now is a half, okay, of ln 3 minus ln 5 plus ln 3, okay, because remember we've taken out half here and you're multiplying in, okay, and what we're gonna say is it's gonna equal what? Well, we can take out firstly, let's make the maths easier. We'll say a fifth minus a third. Okay, so what we get then is a half 3 minus ln 5 plus ln 3 minus 3 over 2. So give me negative 2 over 15. Okay. And let me get another page here. Okay. Then from here, well, what we've got then is 2 ln 3 minus ln 5. Okay. And negative 3 over 2 times negative 2 over 15. Well, that is 6 over 30, which is going to give me a fifth. Okay, now we've got a fifth, so we can say then fine. We're now going to get half ln 9. Okay. Sorry, no. We're going to get half. We get 2. So we get ln 3 squared minus ln 5 plus a fifth. Now, why am I doing that? Because remember, it's the rules of ln. It's the log laws. Okay. And then from here, I can then say, okay, cool. What we get is a half ln 9 minus ln 5 plus a fifth. And applying log laws again, we're going to get a half of ln 9 over 5 plus a fifth. Okay. And that is going to be our final answer, guys. And that's what they're looking for. Okay, half ln 9 5 plus fifth, and that's what we got. Alright, guys, now for this question, it's all about knowing the form that we have to put the partial fraction in. Okay, so what I'm going to say is the following. I'm going to say, fine, let 2x squared plus x plus 8 over 2x minus 1 x squared plus 2 equal a 2x minus 1 plus bx plus c over x squared plus 2. Now you're asking me probably, Nick, why do we do this? Well, we do this because if you see on the screen now, you'll see that this is the key form for the partial fraction when you've got an x squared denominator on the bottom. So one of the elements of the product is a x squared denominator, or x cubed denominator, or xn denominator. Okay, so that's the form we have to put it in. And now what I'm going to say is just do the same thing that we've been doing before. So I'm going to say, fine, 2x squared plus x plus 8 is equal to a x squared plus 2 plus bx plus c. And what I'm going to do, guys, is I'm going to multiply that by 2x minus 1. Okay. Now what can I do? Well, I can just isolate the A. How do I isolate the A? We're going to isolate the A here by saying, fine, let x equal a half. Now, if x equals a half, what we get is 2 times a half squared plus a half plus 8 is equal to 9 over 4a. Okay, cool. And meanwhile, if we plug in half into 2x minus 1, what we're going to get is we'll get 0. Okay, hence this whole thing is going to equal 0. Alright, so from here we can solve for a. So 2 plus half plus a half plus 8, well, that's just going to be the same as saying, well, that's going to add up to 9. Okay, so 9 is going to equal 9 over 4a, which then tells me, guys, that a is going to equal 4. Okay, perfect. Now I'm going to say let x equal 0. Now if x equals 0, what are we going to get? Well, if x equals 0, guys, what we're going to get is, firstly on the left hand side, we're just going to get a value of 8. And that's going to equal 2a. And then c, 2 minus 1. So it's going to equal 2a minus 2a minus c, basically. Okay, now we don't know c yet, but we know a. So 8 is going to equal 2 times 4 minus c. Okay, so c then is going to equal what? C is going to equal 0. Because this is going to be 8. 8 is equal to 8 minus c. C is equal to 0. Alright. Now lastly, I'm going to say, fine. What can I let x equal? Well, if I let x equal 1, I've got c as 0. So if I let x equal 1, we're just going, this bit here is just going to turn to b, which is going to allow me to solve for b as a result. So I'm going to say, fine, let x equal 1. Okay, if I let x equal 1, what am I going to get? Well, I'm going to get 2 plus 1 plus 8 is going to equal 3a plus b. Okay, and obviously 2 minus 1, that's just 1. Okay, so we got 11 is equal to 3a plus b. Okay, but we know that a is equal to 4. Therefore 11 is equal to 3 times 4 plus b. Therefore b is going to equal what? B is going to equal negative 1. And so what can we say? Well, we can say then, guys, that the following is true. Okay. And have 4 over 2x minus 1. Okay, and b, negative 1. X, and c, well, this is 0. So it's going to equal just minus so c equals 0. Alright, but remember that b is equal to negative 1. Okay, so it's just going to be minus x over x squared plus 2. And that is going to be the answer. Okay, but now, they say, fine, Showing full working, find the integral between 5 and 1. Okay, in the form ln c. Okay, fine. Well, to do that now, what I'm going to say is fine. So for I say 5, 1, fx dx is going to equal 5, 1. I'm just going to plug this bit in. So 4 over 2x minus 1. That's x over x squared plus 2. Okay. Dx. Which is then going to give you what? It's going to give me 5, 1, 4 over 2x minus 1 dx minus 5, 1 x squared plus 2 dx. Okay, perfect. So then what can I do? Well, knowing that we want to get in the form f dash of x over f of x, what can I do to this? Well, what I can do is I can take a 2 out here and put a 2 up here. Okay, because why? 2 times 2 gives me 4. Okay? Boom, so we got that. Then I can say fine. Minus 5, 1. We got x over x squared plus 2. Well, what I can do here is I can put half here. Put 2x at the top. Okay, why? Because half 2x is equal to x. Okay. So we haven't really checked. We've manipulated the fractions, but we haven't changed them. Okay, and we've got them in the form of f dash of x over f of x. So from here you can just roll with it. So we can say fine. We got 2. Okay. Look at the 5 and 1 up here. What we've got is ln 2x minus 1 between 5 and 1. Okay, minus a half. Okay, ln x squared plus 2 between 5 and 1. Okay, and this is going to give me what? It's going to be 2 ln 9 minus ln 1 minus a half ln 27 minus ln 3. Okay. This is going to be what? It's going to be 2 ln 9. Okay, minus a half of ln 27 over 3. Okay, which is going to give me what? This is going to simplify now using the log rules to ln 9 squared, which is ln 81, minus a half ln 9, which is the same thing as saying ln 81 minus ln 9 to the power half. And what's something to the power half? It's the same thing as saying square root. So we have ln 81 minus ln 3, which then gives me ln 81 3, which gives me ln 27. Okay, and ln 27 then is going to be our final answer. So is that the form they wanted? Yes, it is. Ln c. And this is the answer to the question as required.